Every block of C# code that you write consists of a sequence of one or more statements, which together describe what that block of code does. Each of those statements describes some actions that you want to perform, ranging from a simple variable value assignment to a complex calculation that requires reading and processing data from a variety of sources. C# describes many different kinds of statements, many of which you'll explore in this course. Some of the more common kinds of statements include things like declaration statements. These introduce a new variable to a code block. You can simply declare the variable or initialize it as well. If you're declaring a constant or using the var keyword, the initialization is required. Another kind of statement is an expression statement. This generally performs some kind of calculation and then stores the result in a variable, or performs some kind of action. Selection statements let you branch execution to different blocks of code based on some kind of condition. Iteration statements let you repeatedly execute the same block of code, perhaps to loop through and process each item in a collection of data, or to perform the same actions repeatedly until some condition is met. Jump statements let you jump to another section of code, such as to short-circuit a loop execution when some condition is met, or to return to the calling code when a method completes execution. And exception handling statements let you respond gracefully when a problem occurs in your code, letting you execute specialized code that performs actions, things like fixing the problem, logging it, or notifying the user that something has gone wrong. And there are several other kinds of statements that defy categorization. An interesting special case of a statement is an embedded statement. Some kinds of statements, particularly the iteration statements that I mentioned before, always contain an embedded statement, which could be a single statement or a long, complex block of statements delimited by curly brackets. The block itself is a kind of single embedded statement, which is a bit weird since a block statement can contain multiple statements. So just kind of get used to that weird way of thinking about statements. Consider the code that I have highlighted right here. These are the statements that make up the body of the statement block method. So how many statements do you see? 4, right? 1, 2, 3, 4. Well, no. Actually, there are 5 statements. So the first one is the age declaration and initialization. Second is the message declaration. The third is this code block, so the open and closing brackets. The fourth is this declaration for full message. And the fifth is that statement right there. So notice that all but the code block end with a semicolon. Further, the code block statement itself doesn't by itself perform any action. It's just a way to delineate code and embed it in another statement. Okay, now in this case, it's not being embedded in anything. This is just a code block that I've delimited with brackets, but it's not embedded within the statement here. So proximity doesn't necessarily make this an embedded statement. There are other times where it is an embedded statement, and here's one right here. So this is a statement embedded within the declaration of statement block. Okay, so the important idea here is that a C# statement can be structural as well as perform actions. Now let's talk about expressions. Informally, a C# expression is a combination of operators and operands that generally have or produce a value. The simplest expressions are literal values, often just referred to as literals, such as 5 or hello world, a string. A variable that contains a value is an expression. Or you can define an expression that uses operators to perform some action to produce a single result value, such as adding 2 integers. You can also create arbitrarily complex expressions by combining values with operators and nest expressions within other expressions as deeply as you care or need to. Consider this code in the calc hypotenuse method. This is in the language features sample project. The code here calculates the length of the hypotenuse of a right triangle using the Pythagorean theorem, which states the square of the hypotenuse, the side opposite the right angle, is equal to the sum of the squares of the two sides adjacent to the right angle. Mathematically, that's expressed as a squared plus b squared equals c squared, where a and b are the sides adjacent to the right angle, and c is the hypotenuse. Now, don't stress over the math. If you don't remember algebra and figuring out sides of triangles and so forth, don't worry about it, because I've expressed that theorem in a C-sharp expression already for you. Okay? But on the other hand, a large part of being a programmer is dealing with math, so it might be something you want to get back up to speed on. Okay, so I initiate the side 1, side 2, and set them equal to 5 and 10. And then I declare the hypotenuse, and these are all as doubles because I'm going to have, they're essentially floating point values. And I'm going to use math.square to raise side to the second power, add to it side 2 to the second power, and take square root of that, and that is the length of the hypotenuse. And then I write out the value that I discovered. Now, it's a bit surprising. This is not complex code, even though this calculation here is starting to get a little bit complex. But there are a lot of expressions in this relatively simple code. The first line of code here is a declaration statement for the side 1 and side 2 variables. And it initializes the variables with literals. And each of these literals is an expression, as is the assignment, as is the statement that declares this. Okay, but more interesting is the second line of code. At the highest level, this is another declaration statement for the hypotenuse variable. So I'm declaring it as a double there. And then at the top level of the calculation, I'm calculating the square root of a value. And I'm using the SQRT method of the math object to calculate that square root. And then this nested expression, because this whole thing is an expression, consists of yet more expressions. So there's two expressions that are joined with a plus sign. That's an operand. So this gets back to that definition of an expression that I mentioned, a combination of operands and operators. So actually plus is an operator. And then each of these expressions is calling the pow method, which raises a value to a power, some power that I specify. And then each of these is an expression as well. This is a variable expression, and this is a literal expression. Okay, then the third line of code is technically a method invocation expression, that is, an expression statement. So this demonstrates that an expression has to do something rather than just calculate a value. In this case, the nested expression passed as the parameter here, that's string value, is a complex expression that isn't by itself an expression statement. Because if I just had this line of what I highlight here, as a line of code and put a semicolon after it, the compiler will complain. This is not a standalone statement. So it's not an expression statement. Okay, but a method invocation that receives that expression is an expression statement, because WriteLine does something with the value of the expression. It writes it to the console window. Okay, so to make the point clear, you can't just add a semicolon to the end of an expression and have it be a statement. So I'm going to remove the commenting there. And you can see immediately the real-time compiler complains, and I get red squigglies underneath everything. So here I have an expression, but it's not an expression statement because I'm not doing anything with that too. Here I'm doing something, but I'm still not doing anything with the value of that expression, that addition. And then once again, this is just a literal value, a string, that I'm not doing anything with, so it's not an expression statement. So if I have an expression here, and I do something with it, in this case assign it to hypotenuse, then now I have a statement, a valid statement that's doing something. Okay, so these are not valid statements. I'm going to hit Control-Z to put the comments back there. And now the compiler is happy because it's going to ignore that code. Another interesting expression that you can use as an expression statement is an assignment. And that's what's happening here in this assignment expressions code. So it might be a bit counterintuitive, but assignment expressions do produce a value, the value being assigned to the variable. So this lets you write code like this. So I declare a counter variable as an int, and then within this method call, I have a parameter where I am assigning the value of 15 to the counter variable. Because the value of this assignment is the value being assigned to the counter variable, the WriteLine method gets the value 15 that's passed to it. And as a side effect, counter now is 15. And so when I execute this statement, this will once again display 15. Okay, so I'm going to go ahead and run this. And then I'll talk about the second set of code in just a sec. And in the sample application, I'm using an additional class in order to display this menu like this. I'm not going to talk about that code here, though. Okay, so I'm going to press C in order to run assignment expressions. And you can see that both of those console statements output 15. So again, I'm assigning the value there. The value of that assignment is 15. 15 is passed to WriteLine, and so that's why 15 is displayed there. All right, that's an assignment expression. Now counter has 15 as its value, and so it once again displays 15. All right, now the second set of code shows how you can use the value of an assignment expression to assign the value of the expression for another assignment. And you can continue to chain those together as long as you want. I'm declaring these three variables, x, y, and z, and then I'm writing an assignment statement like this. So the value of this expression is 1500. The value of that expression is then assigned to y, so y is also 1500. The value of that assignment is 1500, and so x is assigned 1500. So this is an example of some fairly terse C code. It's based on the C language, where you can chain together statements like this. It makes very efficient, very simple to write code, but it does make it slightly harder to read until you get used to these conventions and understand that the value of an assignment expression is the value that is being assigned. Okay? So be sure you're clear on that. All right, so as a result, all three variables have the value 1500, and that's what is displayed. If I go ahead and start that again, runs again, and I'll go ahead and run C again, and you can see that x is 1500, y is 1500, and z is 1500.